Good morning and good afternoon to everybody. Welcome to another Sedaru Live. I'll let everybody get settled in here. We've got a pretty large group for our webinar today, which I think is to be expected a little bit. Last time we did one of these webinars a couple weeks ago. Things certainly look a little bit different. Certainly here in the United States for sure. I think a lot of us are adjusting to some different ways of getting our work done here on a day-to-day basis. It's going to be interesting over the next few weeks and possibly months. What this looks like. As we all deal with the pandemic. And so I'm glad everybody could make a few minutes today to join us for this webinar. We plan on continuing to keep doing these webinars. We might update the frequency of them a little bit as well too, just to keep good information and content going out to the industry. I think as more and more staff are working remotely, and it's a good opportunity to be able to dive into some of these things. If you haven't joined one of these webinars before, just a couple of notes on how we typically run them, so you know and understand. The content, I typically keep the content to 20-30 minutes or so. We try to get these sort of done and wrapped up in under 45 minutes. Lots of time though for you to ask questions. I certainly, what we want is for you to get as much information out of these as possible. And so feel free to ask questions. You'll notice in that Zoom webinar interface that there is a spot called Q&A. So if you hit that Q&A button, you can pop questions in there, and we will get those answered as we go through the presentation. And in general, I've found the more questions that people ask, the better these webinars are. You get it helps deliver the most kind of pertinent information that folks are looking for. So feel free to ask away, and we're gonna get answers into those. I think one note I'll make as well too, and we sent a message out to our Sedaru community. I think towards the end of last week around how we've adapted our operations here. In the last week. So for us in Sedaru, we're already a very digital company, as I think you would expect. And we are extremely good at working remotely with folks. We're extremely good at being able to use all the modern day digital tools to be able to benefit and support and help water utilities. And so in general, we're here to help. So as you have questions about any of those things or not even necessarily Sedaru related, but just of how do I work better remotely? How do I help staff do some of these kind of tasks and some of the tips and tricks? We're full of them. So feel free to reach out to me. Feel free to reach out to other Sedaru staff that you're working with, and we're happy to give advice and guidance and any of our insight. That we can to help everybody here really, like I said, get through the upcoming weeks. So we're going to talk today about the water model, the hydraulic model, and how that can be used day to day to really mostly by non-technical staff. I think most of you will find at your water utility that you have a guy, a gal, a person that knows how to run that hydraulic model. Sometimes that's a consultant that you work with, but in general, it's a limited number of folks that typically are using the hydraulic model. That model's often been developed as a result of a master plan, and sometimes it's just sitting on a shelf. And there's all kinds of benefits and ways that can be put to use, and especially using the Sedaru tools. And so we're going to walk you through the details of that. If you aren't already, find us on social media. Lots of good content there as well too. We'll keep you updated on additional webinars as well. So LinkedIn, Facebook, Twitter, all of those places. While you're sitting here through this webinar, go ahead and pull out your phone and follow us on those on your favorite social media channel there. Lots of good information. You'll hear us talk a lot about this idea of drops, right? And this is our digital roadmap, or our roadmap for cities and utilities, looking at how they're going to make this digital transformation and how you're going to move from being a somewhat of a reactive organization to being able to be more proactive and to be able to use digital tools to get there. And so we'll talk about how things happen digitally and in more real time. And then these ideas of how do I optimize what I'm doing? How do I predict things that are going to happen? And moving towards that idea of a self-driving utility. And when we talk about a hydraulic model, in and of itself, it's already digital in many, but we're going to really be talking about how do I apply this, right? How do I use it, and then how do I get it into people's hands? And so I'm just gonna hop right into the software from here, and we're gonna talk through some different examples. So what you're seeing up on screen is what it would look like generally when I log into Sedaru Omni, right? And so Sedaru Omni is kind of that center place within Sedaru where information comes together, and you're able to see all of the various components together in one place, and to see all your data kind of coming together. If I want to access my water model, I'm just going to swipe over, really, right? And I'm just going to now put me in a screen with a slightly different interface that you see up here. So those KPIs that we're seeing across the top get replaced by buttons that really help walk you through the hydraulic model. And here's really the key with what we're doing with Sedaru modeling is we want to make it so that anybody at the water utility can use the hydraulic model to get information out of it. It shouldn't be limited to that one engineer that really knows all the information, or that consultant that knows things. And those folks are going to add a tremendous amount of value in how you use the model and set it up and to do it. But the idea is how can that average person, how can a field user, how can management, how can the average person at the utility dive in and use the model? So quickly, I kind of just, for folks that aren't super familiar with the hydraulic model, I want to kind of explain, well, what the heck is it? How does it differ from what you might be used to? So what you're looking at on screen here is the GIS, and I'm going to just zoom in a little bit here, and you're going to see, this map update a little bit. And so when you look at your GIS, you've got a collection of pipes, and in this one, valves, and I see hydrants on here. All these M's are individual meter locations. And so you have all of this incredible amount of detail within the hydraulic model, or within your GIS, right? And when we look at the hydraulic model, the model itself is really just another representation of some of these. So I'm going to use these buttons over here. I'm actually going to shut the GIS off, and I'm going to turn the model on. Okay, and so now you see something that looks a little bit different. And in many ways, the hydraulic model does simplify your view of your system in some ways. So it's fundamentally going to be made up of a couple of different elements. I'm going to focus for the moment. We're going to talk about pipes, right? Which everybody should be familiar with what a pipe is, right? Obviously. And so I have a pipe that I've selected here. And you'll notice that that pipe corresponded exactly to a GIS pipe. And that's really generally the trend with building hydraulic models these days, is that you're going to see a relationship between your pipes in your GIS and your pipes in your model. They should be pretty much one and the same. Some folks will have what's referred to as a skeletonized model. So maybe you're only looking at your transmission system, or you're just looking at large pipes in the system. And while hydraulically that can get you very similar results, the trend has certainly been to use models that on a what we call an all pipes model. So you're bringing all those things in. So I can see the pipe in here. I'll give you some information about it. There's some hydraulic information that we'll get into. There's a model ID. There's nodes, which I'll explain. There's a length. There's sort of all this basic information. You'll also see this roughness value in here, which all roughness is a function of what the is a friction factor essentially that just gives you an idea of what the roughness of the pipe is, how much friction there's going to be of water flowing through that, right? So pipes that are relatively new have a much higher roughness factor. Pipes that are older or tuberculated, or that are going to have much more head loss going through it, generally have lower roughness factors. Not something that you really need to get into, and when you're just using the model here, it's more of you're going to use it from a calibration perspective, but we're talking about how we're using it, so we're not going to dig into that. But I just want folks to be aware of that when they see those pieces. And so when I use a hydraulic model, what I get, the data that I get out of pipes is I'm going to see these sort of factors as I see up top here: head loss. I'm going to see velocity, right? So 0.64 feet per second here. I'm going to see flow going through here as well too, right? And so those are the result information I'm going to get out of pipes. I'm looking at what's called an extended period simulation here, and so that means I'm looking at information over time. And so here I can see what the flow in this pipe looks like over time. So on a normal day, I can see at any point in time what I would expect for flow through here. You notice these values are negative, so it just indicates which way the water's flowing through the pipe there on a given day. And so I can see that information from pipes pretty easily. If I switch back here and just want to look at what a node is and what the information here is. So nodes or junctions, as you see them referred to here, are areas within a hydraulic model where water is going to be exiting the system, right? So when we're talking about a water distribution system, this is where your demands come from. Okay, so you're going to have that information is there. It's also, from a calculation perspective, it's also where pressures are calculated, right? So when I look at when I want to understand what the pressure is inside a particular pipe, I'm going to be looking at a node on either end of that pipe, okay, from a calculation perspective. So as you can sort of imagine, then the more nodes that you have in your system, the more points you have within the system to calculate pressure from. And so what you generally see is that folks tend to create nodes when their models are being built. And there's a couple different schools of thought, but generally, where you've got fire hydrants are good places to have nodes. Certainly where you have any kind of changes within piping, so pipe diameter changes, any of those sort of pieces. And then a reasonable number of nodes throughout the system where you might have other valves and just where you've got larger sources of demand. And again, there's a bunch of schools of thought for that in there, but you see here what's typically the relationship here is I generally have nodes where I have valves, and I generally have these nodes or junctions where I have hydrants, which is fairly typical. And then what you also have within your system is things like tanks and pumps and all of those pieces. I'll use the search feature in here. We'll just type in T, and it should spit back for me in a second some search results, and that's going to let me see a listing of elements in here. So I'll see in this particular system, I've got 8 different tanks in the system. I can click on one of those, see information about the tank. This little location button's nice because that's going to now bring me right to the particular location of that particular tank. And so you'll see, I can see that here on the map. And then you see here, I've got a pump station. In this case, there's a well that feeds directly into here as well. And I'll see that here. And so one of the places where you won't typically have exact kind of one-to-one relationships and models is at the actual facility. Sometimes to keep life simpler for everybody, all the individual facility piping might or might not be there, but if it's not there, you're still making a good hydraulic representation of it. So that's kind of the basics in the construction of a model. Now, what we're talking about here is how do we make this model as usable for the average person at the utility, right? And how do we make it as simple as possible for them? And so typically you're going to, I'm going to start with what's called a steady state simulation here. But typically you're trying to have as many of these pipes and nodes and have it represent the real system as much as possible to make it simple so that when somebody looks at a pipe here, it's pretty clear what they're seeing, and they can do that easily. And so I'm just using my mouse on here. I'm running this from the web browser, but I can kind of pan and zoom and see things here. But one of the most common examples or common ways that we see folks that they want to use use a water model would be to check fire flows, right? So you get a developer request into an area, you want to be able to evaluate what's happening at that particular area. So I could say, if I want to, I'm going to zoom in here on this spot and say, hey, I want to check, what's available here for fire flow. So I'm just going to go ahead and I click on that section. You see it selected some pipes, it selected some junctions for me. I've left this one junction selected, and I'm going to come over here to simulate. And then I get to say, okay, what do I want to do, right? So in this case, we want to do fire flow. So pretty easy here. I'm just going to click on the button that says, do I need to meet fire flow? Normally at this location, there's no demand, but I want to see what it looks like if I want to get 1,000 GPM out of there. So I'm going to type 1,000. I'm going to say done, and then I'm going to hit run simulation. Okay, and so this is now running a hydraulic simulation. It's using the EPANet engine, which just about every water model here in the United States is going to use that same hydraulic engine, and it's going to spit out results for me here that's going to show me what the fire flow here looks like. And so it automatically brings up this trend view here. And you see in this case, the area that I chose has significant fire flow capabilities, right? So getting 1,000 GPM out of this location, if we look at the hydrant curve here, we're talking about at 600 GPM, I'm going to have an 85 residual PSI. At 1,200, I'm going to have 80 PSI residual pressure. It is, I can get a lot out of here. And so pretty easy for me to run that quick evaluation and see exactly what's going on and have this whole hydrant curve presented to me pretty quickly. I can then swap back over to my map. And now what's cool is, now that I've run this hydraulic simulation, and I'm going to scroll out here a little bit so you can see a little bit better, you're going to see the whole map is color-coded in here. So I can now see, I can look at the areas here. And so I've got junctions are color-coded. So you see everything that's green is in the 75 to 100 PSI is the range. And then I can also look at pressures in here. So everything that's blue, right, is looking at pressures under 1 foot per second. Everything that's green is in 1 to 4 feet per second. Let's zoom back in and we'll just look at that a little bit here too, right? And so as you would expect, this selected pipe was yellow, right? So it's going to have a relatively high velocity, obviously, because I'm trying to pull that fire flow. The pipes around it are going to have 1 to 4 feet per second velocities, and then and then in and around some of these other areas, we're going to be back under 1 foot per second. And so I can see that information pretty quickly. I also can come over here to this impact tile here. And so the impact tile is going to show me other areas in the system that are going to be dramatically impacted by it. So I see my top 10 changes for pressure in the system in the area. And I can essentially see that, nowhere in my system am I going to have dramatic decreases in pressure as a result of this. And I like the way that this impact is presented, because one of the complaints that you will, or reservations sometimes that you'll hear from folks around letting non-engineers run a hydraulic model is that, well, people don't really know what they're doing with the results. And what we've done here with the Sedaru modeling tool is really kind of lock things down so that what you're running for simulations and your what if scenarios are fairly contained. And then you're able to sort of see the universe of results there as well too, and be able to analyze those things from there pretty quickly. And so it does open up a lot of, it makes it kind of quick to make some assessments from there. If I wanted to then kind of look at this a little bit differently here too. So we know coming in here that that was going to be pretty easy to get what the fire flow that we needed. But now let's say, what happens if we have to do a shutdown over here, right? We've got a large industrial customer here, and we know we've got to do a shutdown. We've got to take part of this main out of service, and I want to make sure that I can still provide fire flow there and to be able to do that easily. So I'm going to select that. I'm going to select this pipe here. You see it highlighted in blue now. I'm going to come back over here to simulate. And you see it's still saying, hey, I want to do 1,000 GPM here. But now I can expand this button that says more changes. And now it asks me, what do I want to do? Am I looking at, do I want to close the pipe? Do I want to make a pipe bigger or smaller? Or do I want to make a roughness change here, right? So like if I was going to rehab this pipe, for example. But let's just go ahead and say we want to close it, right? We got to take this out of service. So I can come here, really simple again. I'm going to say I want to close the pipe. And then it asks me, do I want to do anything more? Nope, I just want to say done. And so now I can go ahead and run the simulation. And so now you see I've got two things listed here. I've got pipe being closed, right? And I've got the 1,000 GPM fire flow going in there. So we'll give that a second to run, and then we'll take a look at the results from that and see what those pieces in there look like. So now we see some results that look a little bit different, right? Before, we were looking at 20 psi, we could get upwards of 4,000, or I think 4,800 GPM out of there. Now we're looking at 3,000, 3,600 GPM out of there. And so that, some of these pieces start looking quite a bit different, So I'm dropped down here, and I can evaluate this and I can see what the effect is of my operation. So I can still get fire flow in there, which is good, obviously. But then we can come back and look at the hydraulic results in here. And so now you see with this pipe out of service, we can take a look at the color coding here. Again, we take a look at our velocities and we realize, okay, hey, we're going to see significant velocities through this section here if we if we need to get that significant fire flow through there. So being able to produce those kind of results really quickly, and you think about sometimes what a lot of your workflows would look like to how you might want to get an answer to that question, right? And does it are you out there wanting to run fire flow tests, all of these sort of significant things that now you can put in the hands of somebody that can run that, from their laptop and be able to do that wherever they're located, at the moment, and be able to do that kind of quick assessment to the system. And so I can then, go in and see that. And then if I want to go ahead and actually be able to kind of share this information with other folks pretty easily, I can do that as well too. So I can come over here and I can hit the share. I hit the share task, and then I can come in here and say, all right, I want to generate, what's the summary of this particular event? And so I can come in, I can fill out, what do I want to title these things, and then put that information in there. Any other recommendation information, I can save these reports out. So I'll just go ahead and save that. And then that allows me to save it out. And then now I'm going to end up with a PDF that I can share with anybody and be able to sort of pass that information along here. So we'll whoops, wrong button there. I want to I'm just going to open up my desktop here. Get to that. Oops. Come on. Where's my desktop? There we go. And I've got in here, here's our PDF report that we'll go ahead and fire that up. And so now I can see an example of what it might look like here. So this was another report, but you get the idea. I can see the scenario that I was running. I can see what the overall demand was. I can see changes that were put in here. And then I'll see a summary of what's going on at the other spots in my system. So we tried to really easily make it so that you can see and drill into, do some of those things in there. So let me hit a couple questions that folks have in here on some pieces. So one was just around modeling scenarios and what can be used in here. Let me go back to the start screen here. And so here on the start screen, you can see when I come in here, you've got a choice to choose different scenarios. So in this case, I've got two scenarios set up in here. There's one that says MDD_SS, which stands for a max day demand. So you know, often for a lot of your sort of design considerations, you're going to be using that max day simulation. And then we've also got that EPS, that extended period simulation set up in there as well too. So you can take any scenario you want out of your existing water model. So whether you're running an Innovize like InfoWater, or you're running water gems, or even just running like a vanilla EPA net simulation, you can export those scenarios out of there and just load them right into Sedaru Modeling. And so here you see here where it says upload an IMP, I can just click on that and have it bring in an uploaded model to me. Let's see, let's see, another question. Oh, somebody asked about flow arrows when the model is, you know, you can't actually view the flow arrows in here at the moment, but that is one of the things on the to-do list here on the Sedaru modeling applications, to add a few more sort of graphical features on some of that, so I can see exactly the flow direction. When I go into any individual pipe, though, I can go in and view results on things, and I can see, you know, the amount of flow and see some of those pieces. See some of those pieces right from there. And let me go. I'm going to switch back into the extended period simulation. Let's look at that a second. So I'm going to switch scenarios here. I'm going to go back into this winter EPS scenario, and you see that's loaded back up for me here. And now let's see, I want to just run a simulation that says, hey, I just want to see what happens if our demands were, instead of, 20 MGD daily demands for this, I want to see, let's say 28. Let's say we have more than we were, typically expecting, and I want to see how that's going to make things behave. And so I can then go ahead and I'll run that simulation, and it's going to produce some new results for me. And one of the things where we see folks using these models to do some of this is when you think about how do you train some of your new staff, right? And again, sort of across the board at the utility, you might be hiring, new staff that don't have a lot of familiarity with water systems in general, and you want to sort of be able to explain, basic hydraulics to them and how different things behave. I can run those kind of simulations right from here. Let me go ahead and I'm going to go back and search for tanks again, because let's go ahead and we're going to look and see what one of the tanks here looks like as a result of that global simulation change that we just made. Let's go out to this one on the west, and so I'll just zoom into it too, so you can see the location of what we're talking about here. And now I can see what is the tank level there going to look like. Let me get rid of this curve here so that it looks a little bit better. So now what's neat here is in these simulations, I can look at what do the before and after look like. So the before, I can see what a normal day would look like. But then if I have higher demands, what I'm going to see is kind of what you would expect here, right? That tank's going to drain faster than what we typically would expect. There's controls built into here that say, okay, when this tank level gets down to this particular level, it's going to go ahead and turn on a pump. And, and so I can essentially see how the operations of my system would start changing as a result of that simulation. So pretty neat stuff that I can do here on that EPS simulation. I can do a similar sort of piece here of saying, and this happens inevitably with places, right? Is that, let's say you've got a large leak somewhere that you're still trying to, you're trying to figure out where it is or where it's coming from. I could pick a spot in my system and say, let's go over here. We'll pick one of these nodes over here, and we could come in, and I'm going to come over here to simulate, and I'm going to get rid of my demand change here, but let's just say that I want to make a demand change at that junction. And let's say I've got a, really large leak that's going somewhere and I can't find it, but I want to see if I have 3,000 GPM coming out of this location, what's that now going to do to my system? Am I going to be able to manage that kind of leak? Am I going to be worried about drawing down a tank or dealing with any of those kinds of pieces here? And so we'll let this update and run here and take a look at the results from it. All right. So we got some results in here from that. Obviously, you see the velocity updated in here. But what we're really more interested in is what's this tank here going to look like? So I just clicked on that tank. I can come into it here, and now I'm going to go in and pull up the graph of this tank again here too. And again, I get the same kind of before and after. And so I can see, again, same kind of idea here. That tank's obviously going to get drawn down, much faster. Normally we'd be looking at that tank drawing down, till 6 o'clock, but by noon it would be down at its low level. We'd be turning those pumps on, and we can kind of see how that cycle here would continue to repeat itself over the simulation. So even with that leak, it looks like you'd be able to do that, but you'd obviously be running those pumps, or in this case, I think it's a well that feeds in there. You'd be running that more often, right? But you can, again, sort of quickly make that hydraulic analysis here. And then one of the other neat things that you can do now when I'm running all of this within Sedaru Modeling is I have that ability that if I go in here and just show a little bit more of the system here, that if I come in here, I can turn my GIS on as well too. So now right from my water model, I've got the ability to come in here and say, hey, well, what are we working on here, in the system? Do I have other work orders that are going on? I've got other pieces going in here. I've got folks working on, I've got other sort of complaints coming in here. And so I can see all that information together in one place. And then if I want to really drill into it, I just swipe back into Omni, and it's going to zoom me right back into that same place. So I can come in here and say, okay, we were doing some customer work there, not too long ago. I can turn on my tasks and I can look for, do I have any open work orders in that area? Do I have anything I need to worry about there? And it looks like in that particular spot, there's not one specific item I need to worry about, but I can come in and I can kind of investigate everything that's going on. And so those kind of things too, it really help make sure that the model itself doesn't just become siloed and is not being used by as much of the staff as you would like. Let's see, a couple other questions. So now's a good time too to get additional questions in here. One of the questions that popped up is how calibrated does my model need to be, right? And we hear this kind of question a lot, right? And it's always it's interesting. The model calibration is its own sort of topic, and how there's a lot of sort of, I guess, varying opinions on how your model can best be used on some of these pieces with that. But in general, what I find is this, right? You're going to have typically had a model built for master planning purposes at some point, probably relatively recently, right? Again, depending on how often you're doing your master plan, or how often you're doing your master plans. Those models typically work really well for things like fire flow analysis and for sort of rough design work, and that's typically where you're building those. And so those models you can oftentimes just dust off and be able to use, especially when you think about fire flow, because you're applying a lot of demand to places. And so if your demand allocation isn't, the latest and greatest and all that, it just doesn't matter that much. Obviously, if you've had like significant hydraulic changes in your system since you last did it, you're going to want to update the model, right? You've gotten rid of a pump station, you've, added significant, new piping to areas, you've changed sources around, anything like that, of course you're going to do that. But you'd be surprised at how well you can take an existing model off the shelf and apply it for a lot of sort of kind of coarse analysis on things. And then the other piece of that is that nowadays it also is relatively straightforward to take a model that has been built for a master plan and then to update it with kind of latest and greatest information to do more refined analysis. So to take all your existing demand information and be able to put that in there and to do those kind of updates is a relatively straightforward process that we've got an engineering services team that can help complete those kinds of analysis for folks and to update those pieces pretty quickly. But then what I really like about putting the model in more people's hands here is that you're going to get better feedback right away from it, right? So if you're seeing a fire flow that doesn't make sense in the model versus what you're seeing out in the field, and you probably have a closed valve, you're going to identify those things right away. And oftentimes, if you're expecting your model to find those things during a calibration process, you're going to be disappointed because there's just limited time and budget typically set aside for model calibrations. And using it on an ongoing basis, you're going to continue to find a lot of those issues and problems and to be able to do that really quickly. Let's see, another question here. Oh, is there a similar model for wastewater collections and treatment? Not yet, actually. Good question, though. I mean, so we're doing some very interesting things there on the wastewater side. So one of the, if you're using like our Sedaru CIP tool, you can do things like upstream and downstream traces and a bunch of those sort of pieces where you're utilizing some network connectivity for more intelligence on pieces. We're not today running a hydraulic model for wastewater or gravity systems. I mean, all of this is applicable to sort of force mains, obviously, but not for a gravity system. And I think you're going to see we have some work underway from an R&D perspective, and at some point you're going to see us do something there on that wastewater front. It's not quite as straightforward as the distribution modeling. One of the nice things about water distribution models, at least in the U.S., everybody uses, EPA net has become a standard that's used by everybody. It works really well. If you look at hydraulic engines within the U.S., there's just a much bigger mix of them, right? They're not standardized as much. And then you can also make the argument that from the wastewater side, needing like a fully dynamic hydraulic engine that does full backwater effects and all those things can sometimes be a sledgehammer for a nail for a lot of the kind of day-to-day issues, right? If I wanted to just have a model to do wastewater capacity analysis and some of those pieces. So there's still different things we're working out from an R&D perspective, because one of our goals on any of these tools is going to be to roll something out that is usable by everybody, right? And so if you need a degree in hydraulics to be able to run the model, then that kind of defeats the purpose on our end. So we have some stuff in the works. You're going to see, you'll see something from us in the future on the wastewater side of things. Well, good. We're getting to the end of our time here. I want to wrap things up. One last question I'll hit on here from folks that. There were a couple folks that asked it, and I'll sort of pop it in here. Is what does it look like to actually be able to license and run this? So it actually stands up incredibly quick, right? So you're running this from a web browser, so you don't need a dedicated desktop computer. You don't need any sort of fancy equipment, and essentially you're able to just license the software. We're able to load things into here pretty quickly, and we can do online training with it and have people up and running, really quickly with it. So if you're looking at today and saying, gosh, why can't I use my hydraulic model? Wouldn't it be great to have this in my hands? It's something we can do pretty quickly. And typically quite a bit less expensively than what you've been doing with your existing hydraulic modeling software. So Lots of options. Lots of options in there on how to do that. Well, good. Well, thanks everybody for the questions today. Thanks for joining us. Like I said, stay tuned to your email and social media. We're going to keep cranking out as many of these webinars as possible in the coming weeks, and keep a lot of good information coming to you guys. Everybody will get a follow-up email from this webinar as well too. So if you have other questions or thoughts you want to share with us, let us know, and we'll do our best. Thanks again, everybody, for your time. Stay healthy out there, and we will talk to you soon. Thank you.